Dear students, today's topic is the payoff matrix of a game. So, the strategic interaction can involve many players and many strategies, but we limit ourselves to two-person games with a finite number of strategies. This will allow us to depict the game easily in a payoff matrix. It is simplest to examine this in the context of a specific example. Please look at the table. Let there are two people who are playing a simple game. Player A will write one of the two words on a piece of paper, that is top or bottom. Simultaneously, person or player B will independently write left or right on a piece of paper. After they do this, the papers will be examined and they will each get the payoff depicted in table. If A says top and B says left, then we examine the top left hand corner of the matrix. In this matrix, the payoff to A is the first entry in the box, that is 1, and the payoff to B is the second entry, that is 2. Similarly, if A says bottom and B says right, then A will get the payoff of 1 and B will get a payoff of 0. So the player A has two strategies, like he can choose top or he can choose bottom. These strategies could represent economic choices like raise price or lower price, or they could represent political choices like declare war or don't declare war. The payoff matrix of a game simply depicts the payoffs to each player for each combination of strategies that are chosen. Here question is, what will be the outcome of this sort of game? The game depicted in this table has a very simple solution. From the viewpoint of person A or player A, it is always better for him to say bottom, since his payoffs from that choice is 2 or 1, which are always greater than their corresponding entries in top, that is 1 or 0. Similarly, it is always better for B to say left, because 2 and 1 dominates than other payoffs 1 and 0. Thus, we would expect that the equilibrium strategy is for A to play bottom and B to play left. In this case, we have a dominant strategy. This is one optimal choice of strategy for each player, no matter what the other players does. Whichever choice B makes, player A will get a higher payoff if he plays bottom. So it makes sense for A to play bottom. And whichever choice A makes, B will get a higher payoff, and whichever choice A makes, B will get a higher payoff if he plays left. Hence, this choice dominates the alternatives, and we have an equilibrium in dominant strategies. Please look at the table. If there is a dominant strategy for each player in some game, then we would predict that it would be the equilibrium outcome of the game. For a dominant strategy, which is a strategy that is best no matter what the other players does. In this example, we would expect an equilibrium outcome in which A plays bottom receiving an equilibrium payoff of 2, and B plays left, receiving an equilibrium payoff of 1. Therefore, the bottom left consisting the payoffs 2 1 is the equilibrium point where dominant strategy achieving. So this is all about payoffs matrix of a game. Again I am saying that the equilibrium out of this game is, the strategy is bottom left, bottom for player A, left for player B. The corresponding payoffs are, equilibrium payoffs are 2 1, and this is also dominant strategy. So the player will play bottom, player B will play left, consisting of payoff 2 and 1. Thank you.